Welcome everyone. Today we will see one of the most fantastic mathematical puzzles in computer sciences, Josephus Problem. So these problems have some logic related to mathematics and codings, and it makes it perfect for strengthening your problem solving skills. So it's who is solving the Josephus problems through the simple steps. So this is agenda, understanding the Josephus problem from story to mathematics. It's like a coding solution applications. So here our plan for today's session is understanding what the Josephus problem is and its historical story. And then we will translate the story into a mathematical approach. Then to changing this story to mathematical approach, we will implement the solutions step by step in coding. And finally, we will see some application where its concept is actually it is used. So coming to this, what is Josephus problem? It is a famous theoretical puzzle in mathematics and computer science. Okay, so the Josephus problem is about a group of people standing in a circle. You can see in the diagram, right? So group of people standing in a circle, and they are eliminated one by one in a fixed setup order until one remains. That means only one person should be surveyed at the end of the game. Okay, so the challenge here is to find the position of the last person standing without simulating the entire process manually every time. Okay, so it's named after the historian Josephus Flavius, that person name is, who used these strategies to solve his life. So from story to math, here I have given some example like n equal to 5. That means we are going to take 5 people. Okay, and k equal to 3. K equal to 3 here means every third person is eliminated. Okay, so that means we have to take 5 peoples, and it is numbered from 1 to 5. As the previous diagram, we have to number the person from 1 to 5, and every third person will be eliminated. Okay, so step 1, you have to start from 1 and count to 3 and remove the person 3. Okay, so the remaining peoples there is 1, 2, 4, 5, as like the previous diagram. Okay, and again you have to start from the 4th people and count to 3. That means 4, 5, and remove the person 1. Okay, so remaining we have 2, 4, 5. Okay, and coming to step 3, again you have to start at 2 and count to 3, remove the person 5. Okay, remaining we have 2, 4, and start at 2 and count to 3, remove the person 2. Finally the surveyor is 4. Okay, so this step by step elimination make it easy to visible the surveyor. Okay, so you have to arrange the person 1 to 5, and you have to start from 1 and count to 3 and stop and remove the person. Okay, again you have to start from the next person and count 3, remove the third person. So according to that, you have to do final surveyor is only one person should be surveyed. So according to this 5%, the surveyor here is 4. Coming to this circular linked list algorithm, so to stimulate this mathematically, we will use a circular linked list. Okay, you just imagine the people forming a circle, as we discussed earlier, using the circular data structure. This is a perfect fit. Like the player starts from 1 to 5. The total number of air is 5, and it's arranged in circular order. So each node represents a person here, and we move the node by node, counting up to kth, and remove the kth node. That means you have to start from 1 and count up to 3. 1, 2, 3. Remove the third person first, and again you start from 4, count 3, 4, 5, 1, and eliminate 1. Again you have to start from 2. Already 3 was eliminated. So according to that you have to do. So in the final person, as we discussed earlier, the surveyor is 4. So this is the program to eliminate a person from the circular linked list. Okay, so first we need to define a node structure for a circular linked list. Here the structure name is node, and we need to get a player ID. So the player ID, it should start from 1 to n numbers, as you all know, and we need a pointer to link the next player. So that's why we assign struct node asterisk next. Next we need to declare a global pointer. So that's why we declare some global pointers here. Like start is used to start from the first person, and next pointer, and to assign a next person we need a new node. And coming to next, here we assign some global variables like n, k, I count. N is for inserting a players, k is for step size, I is for looping variable, and count is for to find the players left. And next two statements are as the user for number of players. Here I'll give some 5 players from 1 to 5. And next two statement for ask the user for step count k values. So here we will give k equal to 3. And next we need to create a circular linked list. Okay, so first we need to assign a memory using the syntax struct node mllog function size of struct node. And after the memory is allocated, we assign the node name is start, because we are going to start from the player 1. So that's why we assign the start. And we need to assign that player ID the first person. Okay, that means how to assign to the node to the 1 means start is a node name. Start of player ID equal to 1, because the first field is called as player ID. So start of player ID equal to 1. And finally PTR equal to start is pointer points to player 1. That means start of the test. Next we need to create a remaining nodes. So for inserting the remaining nodes, we can go for loop. Okay, so in the for loop should not start from 1, it should start from 2, because 1 was already created a first node. Okay, so we started from I equal to 2, I less than n means it should be 5, I plus plus. Okay, and next we need to create a memory for new node to assign the place numbers. And next we need to link the previous node to the new node through the statement ptr of next equal to new node. Okay, And next we need to assign the player ID through I variable. How we initialize 1? Here we can get I. That means for I already we run that looping from 2 to 5. So according to that we get 2 to 5 numbers. Finally PTR equal to new node. That means move the pointer to the new node. Because it is a circular linked list, last node should be connected to the first node. Okay. Next we need to start elimination process. That means we need to repeat until only one person is left. Okay. So the for loop we can move k minus 1 steps forward each time. Okay. And move the pointer to the next player through this for loop. Okay. I equal to 0. I less than k minus 1 I plus plus. Okay. And PTR equal PTR of next. And next delete the kth player to the target. Okay, that means PTR of next equal to PTR of next. That means you are bypassing that particular player. Okay, bypass the deleted node. Automatically the memory is not free here, but program still works. Okay, finally printing the deleted players. Okay, and you know, right, our intention is we need to find out the winner, I mean that surveyor. Okay, so the winner in the player is PTR of player ID and return 0. So this is the program to find the winner. Okay, that means surveyor from the first 5 persons. So finally you can see here as I said you, here we have given n equal to 5 and that kth position to be deleted k equal to 3. Okay, you just entering 5 numbers and the value equal to 3. The first third person is deleted and which starts from 4 and 1 is deleted. Again we starts from the next person 2 and delete the 5 and already 1 was deleted, we start from 2 and we start from the next and we deleted 2. Finally 4 is a winner. So this is a final application. Like you might be wondering why is this problem important, right? Here where it's used. Okay, first operating system scheduling, the processor killed or scheduling in a cyclic order. Okay, and coming to the network token passing, this network token passing is used in ring networks. Here we are using this applications. And memory management, like garbage collection often uses circular travelers today. And gaming stimulation for turn-based elimination. In the gaming, right now we are using this application. So this is more than a puzzle. It's a real world problem solving techniques. So that's all for today. We learned how to approach a classical math problem step by step and code it and see its use cases in the real world. Thank you.